Hi there. In this video, we will compute the mode for three common data series. Recall that the mode is a measure of central tendency, and it is the values in a dataset that occurs most frequently. So we have three datasets that we'll be using to show you all the different ways that you can be asked to compute the mode in your examination or test. The first dataset is an individual series dataset on the number of times that 9 children have been vaccinated since birth. The second dataset is a discrete series dataset on the number of dental clinic visits of 10 children in the last 1 year. This is a discrete series data because we can see the variable and each value of the variable has its corresponding frequency. Then the third dataset is a continuous series dataset on the weight in kilograms of 10 children attending a nutritional clinic in Samaru Zaria, Nigeria. This is a continuous series. As we can see, the data is grouped with frequencies for each class. Alright, so we have these three datasets with all the possible scenarios that you can have in an examination or even a real-life scenario. Let's do this. Mode of individual series data. This is the dataset of the number of vaccinations per child received by a sample of 9 children in Samaru Zaria. This is an individual series data because each number here represents the data from one child. Let's find the mode of this data. Recall that we said that the mode is a measure of central tendency that indicates the most frequent value of the dataset. So our task here is simply to find the most frequent value, right? To do this, we need to first arrange the data in ascending order so we can see all the same values together. Next, we observe to see which value has the highest frequency. For the first value, 0, it occurs only one time. For the second value, 1, it occurs 3 times. 3 occurs 2 times, while the fourth, fifth, and sixth values each occurred only once. So we can see clearly that the highest frequency is 3 and the value with the highest frequency is 1. So the mode number of visits is 1 visit. Easy peasy. The mode of discrete series data. This is a discrete series dataset on the number of dental clinic visits of a sample of 10 children in the last 1 year. We know that this is a discrete series data because we can see the variable and the corresponding frequencies, right? So how do we find the mode of this data? Recall that the mode is a measure of central tendency that indicates the most frequent value of the dataset. So our task here is to find the one with the highest frequency. When we look under the frequencies, we see that the highest frequency is 5. And the value with the highest frequency is 1. So our mode number of visits is 1. Easy peasy. Mode for continuous series data. This is a continuous series data on the weight in kilograms of 10 children attending the nutritional clinic in Samaru Zaria, Nigeria. We know this to be a continuous series because we can see that the data is grouped and the frequency for each class is provided. So how do we find the mode of this type of data series? Recall that the mode is a measure of central tendency that indicates the most frequent value. So we'll be looking for the most frequent, right? Let us modify this table a bit to make it easier for us to compute the mode. So let's place the weights in kg here and the frequency here. And then we have all the data arranged neatly in a vertical manner like so. Awesome. The mode of continuous series data is given by the formula. Z equals L plus open parenthesis f sub 1 minus f sub 0 divided by 2 times f sub 1 minus f sub 0 minus f sub 2, close parenthesis, multiplied by lowercase h. Here, Z represents the mode, L is the lower limit of the modal class, f sub 0 is the frequency of the class preceding the modal class, f sub 1 is the frequency of the modal class, f sub 2 is the frequency of the class succeeding the modal class, and h is the size of the class interval. So let us apply this formula to find the mode of this data. First, we need to identify the class with the highest frequency, and this is called the modal class. The highest frequency is here, 7, right? And this belongs to the 5 to 10 kilograms weight class. So this is our modal class. And so the lower limit of the modal class, L, is 5. The frequency of the modal class, f sub 1, is the highest frequency, and we already know that to be 7. The frequency of the class preceding the modal class, f sub 0, is 1, and the frequency of the class succeeding the modal class, f sub 2, is 3. And the size of the class interval, h, is... So if we're using the modal class, the lower limit of the next class minus the lower limit of this class will give us the size of the class interval. That will be 10 minus 5 equals to 5. Awesome. Now let's plug in all these values into the formula. So Z equals L, which is 5, plus open parenthesis f sub 1, which is 7, minus f sub 0, which is 1, divided by 2 times f sub 1, which is 7, minus f sub 0, which is 1, minus f sub 2, which is 3, then close parenthesis, and finally multiplied by h, which is 5. Great. So we'll have 5 plus 6 divided by 10 multiplied by 5. That will be 8. So our mode is 8 kilograms. Easy peasy. So this is how to compute the mode for individual, discrete, and continuous series data. Now, if you've gained value with this video, consider subscribing to this YouTube channel and share this with your friends and colleagues to help them. And if you want to learn how to compute the median for different series data, check out this video here. And for the mode, check out this other video right here. See you in the next video, and as always, thanks for watching.